Okay, we already know the attribute that is the most important is age because it is the highest. So after we select the age, so we can again calculate. If the age is less than 30, so again we will calculate from the age, income, student, credit rating. Okay. So it comes that the student is the most important. After we remove some of the data, and yeah, we use this split or we use the attribute student for splitting the decision whether it is no or yes. And if you can check this one, 31 until 40, it shows only yes, because based on the result here, yeah, the entropy is 0. And the entropy is 0 means, yeah, it is already completed. You cannot split anymore. So we need to choose only the highest one. So the highest one is still possible to split. Yeah. So now there are some criterion to split. The first partitioning scenario is when you have the A1, A2, A3 until AV is a discrete value. So one branch is grown for its known value of A. It means, let's say if I have, for example, color. So the attribute for every branch, it can be the name of the color. Is it red? Is it green? Is it blue? Is it purple? Is it orange? Yeah. Or let's say income. I have the income low, medium, and high. So every value or every categorical value will be in the branch. Or there is another type of partitioning. This one is when the attribute is continuous value. Continuous value means number. So if it is number, two branches are grown and it corresponding to the A, which is the A is higher to the split point and A is A is less than the split point and A is higher than the split point. Let's say this one income. Okay, I know maybe the income is 50,000, 30,000, 25,000, 60,000, 80,000. So when you create the split, it can be into two, which is less than 42 or higher than 42. So this is the most possible way to split. And the other kind of split, we can have a discrete value and a binary tree must be produced. If you still remember in the algorithm class, we have binary tree. Okay? The binary tree means you need to have only two branches. Okay? Yes, no. Or if we have color, for example, there are many colors. So we can split based on the particular values. If the color is red and green, if it is yes, we go to this left. If it is no, we go to the right. Okay. So we can make this two kind of split. So this kind of scenario, we can use it in the decision tree. The first part, we learn about the information gain. We can use the gain ratio It is for the attribute selection. We can use this one to the algorithm C4.5. I'm not sure why they call the algorithm C4.5. So this gain ratio, it mentioned that the information gain measures, the information gain we learned before, is bias. Bias, it means, yeah, we still have some not good result when the attributes have a large number of values. For example, if the color, as I mentioned to you, color. The previous one, we have only 3 categorical values. So it's very maybe good. The student have only 2, yes, no. The age, we have only 3. Higher than 40, 31 until 40, and then less than 40. But if we have color, for example, we have 20 attributes. Green, orange, blue, red, yellow, black, and so on, until 20 values. Then the information gain will give you some bias. That's why the authors mentioned that we can use the gain ratio. So C4.5 is the successor of the ID3. We use the gain ratio to overcome the problem with this bias. So it will do the normalization to the information gain. How can we do this one? Yeah, this is the split info. Yeah, if you want to learn about this formula, and we can get the gain ratio. How we can get this one? Let's see the example. So now let me use the other attribute. So I'm not using the age. Let's use the income. And I use the income. So I have the income is low. 1, 2, 3, 4. Okay. And then I have the medium. 1, 2, 3, 4, 5, 6. And then high. We have 1, 2, 3, 4. Okay. So the split info for the income, it means I know that there are 4 low, 4 among 14, and I will use the log base 2, 4 divided 14, and then for the medium, I have 6 divided by 14, and then for the high, we have 4 divided by 14. Okay. This is for the high, this is for the medium, and then this is for the low. So the result of the split info will be 1.557. Using the gain ratio, the gain ratio will be used to check the income. Based on the information gain, this one. Okay. So this is based on the information gain that we learned before from the previous one. This is the information gain from the X. This is information gain from the income. This is information gain from student. This is information gain from the credit rating. And we want to normalize. How to normalize? So we will use this value and we will divide it with the split info for the attribute income. So 1.557, it will be the denominator, and then 0.0 29, which is the information gain, it will be divided with the split info income. So we will get the value is 0.019. We can do with the other attribute like the gain for the age. We can also do with the gain for the attribute student. We will also do the gain with the credit rating and then check all the values. So the attribute with the maximum gain ratio will be selected as the splitting attribute. There is another method, we call it Gini index. In the Gini index, or some mentioned as cup, or some of the literatures mention it as IBM intelligent minor. Cup is the classification and regression tree. Cup is the classification and regression tree. Okay. If we use the classification tree, means the target is the categorical data. If we use regression tree, means the target is continuous data. Okay. Now we can use this simple Gini index just based on the probability. We have a data set D contain examples from N class, and we can use the Gini index or Gini D. It is defined by this formula. Pj is the relative frequency of class J in D. D is the data set. So if data set D is split into two subsets, D1 and D2, so the Gini index will be something like this one. And we want to see the reduction on the impurity. We will check how we can get this one. So the attribute that provides the smallest Gini or the largest reduction in impurity is chosen to split below. So it needs to enumerate all possible splitting points for its attributes. Let's see the example. Using the same data, you will see that we have the 9 yes and 5 no. Total we have 14 and yes 9, 5 no. Then we can just measure the Gini index. It is the 1 minus 9 divided 14 power of 2 minus 5 divided 14 power of 2. So we will get the Gini index as this value. Now, I would like to check based on the attribute income. Okay, let me just use the attribute income. In the attribute income, we have three values: low, high, and medium. The rule in this card is to make split into two. Okay, so the splitting is only two. Then we will make T1 and T2. So we will make many options. So if we have three values and we want to make into two, then there will be low, medium, and high. We can have letter medium, high, and low, and we can have letter low, high, and medium. Okay, so if we make into two, then we can have low, medium, and high. We can have medium, high, and then low, and we can have low, high, and medium. So we need to check one by one. Now let's check the first one. We want to check the low, medium, and high. So when we know that the low and medium, we need to check how many yes and how many no. If it is low and medium, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10. So how many yes? Then we need to check 1, 2, 3, 4, 5, 6, 7. So there are 7 yes. And how many no? We will check this one. 1, 2, 3. So there are 3 no. What about if the income is high? Okay, 1, 2, 3, 4. Okay, we have 4. And then we need to check how many yes. 1, 2. Okay, 2 no. And how many yes? We have 2. So we can get like this number in the table. After we have this one, we will make the Gini values by plotting the probability of low medium, which is 10, divided by the total data, which is 14, multiplied by the Gini D1. The Gini D1 means the low and medium. And we will plus with the 4 divided 14, which is the high, multiplied by the Gini D2. So the Gini D1, it means we have 1 minus 7 divided by 10, because we have 7 in yes, power of 2, minus 3 divided by 10, power of 2, plus we have 4, which is from the high, and then multiply by the 1 minus 2 divided by 4, which is from the yes, power of 2, minus 2 divided by 4, this is from the no, power of 2. So we will get the value 0.443. This is when we have the low and medium for the T1 and high for the T2. We need to check the other, which is the medium high. Okay, we can get 0.45. We calculate again for the low high, and we can get 0.458. When we use this Gini, we will choose the lowest. So if we just want to use the Gini, we will choose the lowest one. The lowest one is this one. Okay, so the low medium is the lowest. Then we will use this one as the splitting. So the first, if we use the income, if we use the attribute income, then the attribute income, the splitting will be low and medium, and then this is high. Okay, we can split into 2 like this one. All attributes are assumed. Sorry, this one should be categorical value. Sorry, forgot to change. All attributes are assumed categorical values. Okay. For the continuous values, we will have another way to make this one. Yeah, we can use also the Gini for the continuous, but there is another way. And we may need another tool, for example, clustering, to get the possible split values. It is for the continuous values. So here we are dealing with the continuous values. So the one that we learned before, it is for the categorical values. But what about if we have the continuous values? That attribute A is the continuous value attribute. So we need to determine the best split point for A. And so this is the keyword, best split point. First, we need to sort the value from the increasing order and then we need to check the midpoint between each pair of the adjacent value. So the most possible splitting point is AI plus AI plus 1 divided by 2. So we can get the midpoint. And then the point with the most discriminating power is selected as the splitting point for A. The idea, we can just use the Gini index. Okay, the Gini index is just splitting into 2, which is D1 and D2. We know that D1 and D2, we have only 2. So we can say that the attribute will be less than equal to the split point, and the D2 is the attribute which is higher than the split point. For example, I have this data. I would like to check. This is the target, the chip. And there is another attribute refund, and there's another attribute marital status, and there's another attribute taxable income. 1 to 5K. It means 125,000. 100K means 100,000. So this is continuous value. How we can split this one? So we need to use the binary decision based on one value. Several choices for the splitting value. It means the number of possible splitting value equals to the number of distinct values. So if you want to choose, can we just choose this one as the splitting? Yes, but it will make very huge computation. If I choose this one as the splitting value, then you need to check if it is less than 125. So this one, 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 this one. So it will be computationally expensive. Yeah. That's, even though it is possible, yeah, it is more because the algorithm will be very long. So we want to choose the splitting value, yeah, based on the two different database, which is D1 and D2. Okay. We want to partition with the whether it is less than a value or higher than a value with the midpoint. Yeah, the simple method is to choose the best fee, like this one. For each fee, we can scan the database and gather the count matrix and compute the Gini index. So it is computationally inefficient because it will repeat some blocks. Okay. So as I mentioned to you, if we use the splitting value, let's say we choose this fee, yeah, it will be very computational expensive. So for the efficient computation, yeah, we will just do this way. First, we will sort the attribute, and then we will linearly scan this value. Okay. Linear scan. If you learn in the data structure and algorithms, we have the big O. Okay. If in the big O is n, it is still okay. It is not computational expensive. So it's time updating the count matrix and computing the Gini index. And then we can choose the split position with is the least Gini index. The least, the minimum. So for example, I have the data taxable income, this one to 5K, 1000K, 70, 120, and so on. So we will do the sorting. We sort the value 60, 70, 75, 85, 90, 95, 100, 120, 125, and 220. So I will check this on the first split position. Usually the first split position is just a number less than the minimum value. Let's use 55. So in this 55, we will check less than equal and higher. What is the number of yes and what is the number of no? Okay, we know that less than 55, yeah, there is no data less than 55. But if it is higher than 55, we have 1, 2, 3. Okay, we have 3 yes, and we have 1, 2, 3, 4, 5, sorry, 5, 6, 7. Okay, we have 7 no. Then with on this one, we can calculate the Gini. Okay, the Gini is from the previous example. Now we will do the next. After we check this 60, we want to check the middle between 60 and 70. What is the mid value? 60 plus 70 divided by 2. Then we have 65. So 65 will be the mid value. And we will check again. How many yes if it is less than 65? How many no if it is less than 65? Less than 65? Okay, we have 1 no. And how many yes if it is higher than 65? How many no if it is higher than 65? So we have this result, and we can do again, we can calculate with the G. Again, we will check the next between 70 and 75. So 70 plus 75 divided by 2. So it should be like, okay, it should be 72.5. But we can just round it to 72. We put this is at the mid value, and then we calculate again. What is the value of yes if it is less than equal to 72? What is how many no if it is less than equal to 72? How many yes if it is higher than 72? And how many no if higher than 72? And we can calculate the Gini index. And so on. So we need to check the lowest Gini index. And the lowest is this one. Then we can say that we can use 97 as the splitting value. So if you want to make the taxable income as the splitting, then it should be less than equal to 97 and it is greater than 97, because it shows that it gives you this Gini index. So we learned about the 3 different measures: information gain, gain ratio, and gain index. Maximum, and minimum. It means, yeah, we need to check the maximum value from the information gain. We need to check the maximum value from the gain ratio. We need to check the Gini index. How many typo? Okay, Gini index, this is the minimum. And these three measures in general return good results, but in the information gain, as you know, it is biased toward multi-valued attributes. So if the values are big enough, so it will be biased. So the gain ratio, it will give you a better way from the information gain, but it tends to prefer unbalanced splits in which one partition is much smaller than the others. So if we have a lot of split, yeah, still it has some issues. That's why with the Gini index, it will give you only two options. But still, it has issue, it is biased for the multi-value attribute. And it has difficulty when the number of classes is large. It means if you have only like binary attribute, yes, no. If it is yes, no, it is easy. But if your class is very big, for example, in my research, I'm doing the human activity recognition in Ganbongchang. So there are many activities. Maybe I can detect the sports activity, Nonggu, Shukku, and yeah, you know, there are many activities. And last time we have 400 activities. So it is impossible with the Gini index. And it tends to favor tests that result in equal size partition and purity in both partitions. Yeah, it's usually we have the equal size partitions and purity in both partitions. Yeah, we want to balance between two. This is the D1 and D2. So later we will check if the split is only two, then the dip of the tree will be very, very long. There are other attributes, okay, but we cannot learn all the things. So you want to check all the attributes selection measures, yeah, you can look at the literatures, okay, like G-Chef, G-Statistics, or MDL, multivariate splits, and still there are many more. Okay. And of course, this is based on your data set. You cannot say that this one is the best. Which attribute selection measure is the best? Most give good results. None is significantly superior than others. It depends what is your data set, what is your parameters, and etc. Okay, what are the three possible methods for attribute selection? We have information gain, we have gain ratio, and we have Gini index. Okay. For the information gain, we want to get the maximum. For the gain ratio, we also want to get the maximum values. For the Gini index, we want to find the minimum among the selection. Can you briefly explain on how to split continuous value attribute? Okay, it's a long process, but the simple steps is first you need to sort. Okay? You need to sort the values. After you sort the values, you can scan linearly. scan linearly means you scan one by one and find the mid value. After you find the mid value, and then you will check the count matrix and calculate the Gini index. Finally, choose the least Gini index. So this is the very brief for the splitting continuous value. How about the splitting discrete or categorical value? You can just, if you use the continuous value, you need to sort the values and scan linearly and find the mid value. But for the categorical value, you just need to make the count matrix. So the count matrix means how many yes, and then how many yes with the respective of the age, how many yes with the respective of the income. So you can just make the count matrix and then calculate the entropy. Yeah. And then you will calculate the measures. The measures can be the information gain. It can be the gain ratio. Okay. If you use the Gini index, yeah, you can calculate it with the Gini index. And then select the best one. If you use the info gain, you use the maximum. If you use the gain ratio, you use the maximum. And if you use the Gini index, you will find the minimum. Okay, that's the briefly explanation. Okay, I guess due to the time, let's finish this one.